Hello students. In the last lecture of our part first, chapter number 3, trigonometry function, we studied about the properties of inverse trigonometric functions. The proofs of properties of inverse trigonometric function are deleted from our syllabus, but examples on the topic are not deleted. So, in today's lecture, we solve some examples on inverse trigonometric function and properties of inverse trigonometric function from our exercise number 3.3. So see the first example. Find the principal value of the following. First example under this common instruction, it is sine inverse of 1 upon 2. Means we have to find the principal solution of sine inverse 1 upon 2. So see the solution. We have sine pi upon 6 is equal to 1 upon 2, where 1 by 2 is belongs to the closed interval minus 1 to 1, and pi by 6 belongs to the closed interval minus pi by 2 to pi by 2. And therefore, by using the inverse trigonometric function, we easily say that the value for sine inverse 1 upon 2 is equal to pi upon 6. And hence, the principal value of sine inverse 1 upon 2 is pi by 6. Second example, tan inverse of minus 1. That is our aim to find here the principal value for tan inverse minus 1. Solution, see the solution. We have tan pi by 4 is equal to 1. Also we know tan of minus theta is equal to tan minus tan theta. So use this concept here. Means tan of here, since tan pi by 4 is 1, so the value of tan of minus pi by 4 is minus tan pi by 4. And therefore, tan of minus pi by 4 is equal to minus 1, where minus 1 belongs to real number and minus pi by 4 is belongs to the open interval. Make here correction. Here the open interval minus pi by 2 to pi by 2. Okay. And therefore, tan inverse of minus 1 is equal to minus pi by 4. And therefore, the principal value of tan inverse of minus 1 is minus pi by 4. So the next example, find the principal value of cos inverse of minus 1 upon 2. Solution, we have cos pi by 3 is equal to 1 upon 2. But we know that cos of pi minus theta is minus cos theta. We use this concept here. So here, if we put value of theta as pi by 3, we get cos of pi minus pi by 3 is equal to minus cos pi by 3, it is minus half. And so here we get cos of pi minus pi by 3 means 2 pi by 3. It is equal to minus half. Where this minus half belongs to the closed interval minus 1 to minus 1, minus 1 to plus 1. And this 2 pi by 3 is belongs to the closed interval 0 to pi. And therefore, we get here cos inverse of minus 1 upon 2 is equal to 2 pi by 3. And therefore, the principal value of cos inverse of minus 1 upon 2 is 2 pi by 3. Okay. Now here again we can use the concept of minus theta. Angle of minus theta means cos of minus theta is pi minus cos theta. That concept is again used here. Means this term can be written as pi minus cos inverse of half. In this way you can write this term. But simply using this formula means cos of pi minus theta is equal to minus cos theta, we can find easily the principal value for the given function cos inverse of minus 1 by 2. Now see the next example number 2. Evaluate tan inverse 1 plus cos inverse minus 1 by 2 plus sine inverse of 1 by 2. Solution, Let tan inverse 1 is equal to alpha, where this minus pi by 2 less than alpha less than pi by 2 means alpha belongs to the open interval minus pi by 2 to pi by 2. Therefore, from this we get tan alpha is equal to 1, but 1 is the value for tan pi by 4. And comparing, here we get alpha is equal to pi by 4. We call this as relation number 1. Let cos inverse 1 by 2 is equal to beta, where beta belongs to closed interval 0 to pi. And therefore, cos beta is equal to 1 by 2, and 1 by 2 is the value for cos of pi by 2. Sorry, pi by 3. And therefore, comparing, here we get the value of beta as pi by 3. We call this as relation number 2. Also, let sin inverse 1 by 2 is equal to gamma, where this gamma belongs to closed interval minus pi by 2 to pi by 2. And therefore, we get sin gamma is equal to 1 by 2. It is value for sin pi by 6. And this implies gamma is equal to pi upon 6. Call it as relation number 3. Now we get value for alpha, beta and gamma. Alpha is equal to pi by 4, beta is equal to pi by 3 and gamma is equal to pi by 6. Means value of tan inverse 1 is equal to pi by 4. Value for cos inverse 1 by 2 is equal to pi by 3 and value for sin inverse 1 by 2 is equal to pi by 6. And so now consider here the term having value we have to find here. That is, consider tan inverse 1 plus cos inverse 1 by 2 plus sin inverse 1 by 2. Substituting values of these three terms from relation number 1, 2 and 3, we get it is equal to pi by 4 plus pi by 3 plus pi by 6. Now simplify this, means take this addition. To take the addition, we see 12 is the LCM of denominator, and so if we take 12 as the LCM, in the numerator in first term we get 3 pi, in second term we get 4 pi and here we get 2 pi. And therefore it is equal to 3 pi plus 4 pi plus 2 pi whole divided by 12. Means it is 7 plus 2, 9 pi divided by 12. It is equal to 3 pi by 4. It is the required value for the given inverse trigonometric function. Okay. Now see the next example. Example number 3. Evaluate tan inverse square root 3 minus sec inverse minus 2. Now let here tan inverse root 3 is equal to alpha, where alpha belongs to open interval minus pi by 2 to pi by 2. And therefore tan alpha is equal to root 3, it is equal to tan pi by 3. And so we get alpha is equal to pi by 3. Alpha is equal to pi by 3 means tan inverse root 3 is equal to pi by 3. We call this as relation number 1. Also consider or let sec inverse of minus 2 is equal to beta, where beta belongs to open interval 0 to pi except beta is not equal to pi by 2. Okay. And now here sec beta is equal to minus 2. From this sec beta, we can find value of cos beta. It is minus 1 by 2, which is equal to minus cos pi by 3, because cos pi by 3 is 1 by 2. And now minus cos theta, it is cos of pi minus theta. So it is cos of pi minus pi by 3, it is cos 2 pi by 3. And so on comparing, we get beta is equal to 2 pi by 3. That is, sec inverse minus 2 is equal to 2 pi by 3. Now consider tan inverse root 3 minus sec inverse minus 2. Substitute their corresponding values from relation 1 and 2. It is equal to pi by 3 minus 2 pi by 3. It is equal to minus pi by 3 because here denominator is same. So numerators get subtracted here. Pi minus 2 pi is minus pi. So the value for the given function tan inverse root 3 minus sec inverse minus 2 is minus pi by 3. Next example, example number 4. Find the value of the following. So first example, sin inverse of sin 5 pi by 3. Now here We know sin inverse of sin theta is equal to theta. Using that, we get the answer is 5 pi by 3. But we have to simplify first. So solution, consider sin inverse of sin 5 pi by 3 is equal to sin inverse of sin 2 pi minus pi by 3. We split this 5 pi by 3 as 2 pi minus theta. It is 2 pi minus pi by 3. Now 2 pi minus theta means that angle is in the fourth quadrant, and in the fourth quadrant sin function is negative. And so value of this bracket means sin of 2 pi minus pi by 3 is minus sin pi by 3. Because sin 2 pi minus theta is minus sin theta. Here theta is pi by 3. And therefore we get here sin inverse of sin minus sin pi by 3. Now we know minus sin theta can be written as sin of minus theta. And so it is sin inverse of sin minus pi by 3. We use here the result. Remember that result? Sin of minus theta is equal to minus sin theta. We use this result. Here theta is pi by 3. Okay. And sin inverse of sin theta is theta, and so it is equal to, means sin inverse of sin 5 pi by 3 is equal to minus pi by 3. Okay. Now see the second example under this instruction, means find the value of sin of cos inverse of minus 1 by root 2. Now we know cos inverse of minus x is equal to pi minus cos inverse x. We use this result here. So using this result, the sin of cos inverse minus 1 by root 2 can be written as sin of pi minus cos inverse of 1 upon root 2. Now cos inverse of 1 upon root 2 is pi by 4. So we get it is equal to sin of pi minus pi by 4. Now sin of pi minus theta means angle is in the second quadrant, and in the second quadrant sin function is positive. And so sin of pi minus theta is sin theta. And so it is equal to sin pi by 4. And value of sin pi by 4 is 1 upon root 2. So it is equal to sin of cos inverse minus 1 upon root 2 is equal to 1 upon root 2. This is the solution for this second example under this instruction. So now see this third example. Sin of sin inverse 3 upon 5 plus cos inverse of 3 upon 5. Now we know one result or one property of inverse trigonometric function, and it is that if minus 1 less than x less than 1, then sin inverse x plus cos inverse x is equal to pi by 2. When x is any value in the open interval minus 1 to 1, then the sum of inverse sine function for that value plus inverse cosine function for that value is pi by 2. Now here we observe this 3 upon 5 is again lies in open interval minus 1 to 1. So since here minus 1 less than 3 by 5 less than 1, therefore sin inverse 3 by 5 plus cos inverse 3 by 5 is equal to pi by 2. Now using this value, we get sin of sin inverse 3 by 5 plus cos inverse 3 by 5 is equal to sin pi by 2. And sin pi by 2 is 1. And so value for the given function is 1. Now see next example number 4. Cos inverse of minus 1 by 2 plus tan inverse of root 3. Solution. Cos of cos inverse minus 1 by 2 plus tan inverse root 3 is equal to cos of pi minus cos inverse 1 by 2 plus tan inverse root 3 is pi by 3. We use the result here in the first term of the bracket. We use the result cos inverse of minus x is equal to pi minus cos inverse x. Okay. Now here it is equal to cos of pi minus cos inverse 1 by 2 is minus pi by 3 plus pi by 3. Now minus pi by 3 plus pi by 3 here get cancelled. This term here, the last two terms get cancelled from the bracket. And so now we remains with here cos pi. So it is equal to cos pi, and cos pi is minus 1. And so value for cos of cos inverse minus 1 by 2 plus tan inverse root 3 is minus 1. So these are some examples on inverse trigonometry function. So see you again in the next lecture. In the next lecture, we solve again some more examples from the same exercise. Thank you.